Hi, my name is Janine and I'm so glad you're here today for today's math video on multiplication. I hope you're doing well. I'm doing much better. I'm staple free, and as I reflect on my physical abilities, I hate to admit this, but the truth is I lose my balance frequently and I'm prone to fall. So it looks like I'm going to be able to get some physical therapy here in the next weeks to help me in the area of balance, and I'm very excited about that. And so it's looking like this fall that I took turned out to be a pretty big blessing after all. You're probably way beyond me. I'm just entering my division chapter right now. I feel like I'm always kind of at the end of the pack with my math chapters, but we just finished up multiplication. And this has truly been my favorite year ever of teaching multiplication. I've tried so many different strategies through the years, but this is the one, at least for this group of students, that worked the best. And so if you're past it, don't feel like it's a waste of time to watch this, because you might see something that you can use for next year or something that you can use in your review of that standard of multiplication. So to do this, they need to be really proficient. They need to have mastered the multiplying of the multiples of tens and hundreds. And I bet your students have already mastered that. And then we spend some time reviewing that. And then I spend some time just asking them what this number is. You know, what does this 5 represent? And I was surprised that several of them thought that it represented 5. But many of them knew that it represented 50. And so we really had to spend time going over that so that everybody was at the same place with that. So once they have mastered that, then we're going to break this number apart. This is really 50 plus 3 times 7. And then we are going to do 50 times 7. Then we're going to do 3 times 7. And here's where the one area of error that they ran into. A lot of the students weren't lining up the numbers as they had been taught to add in the past, since first grade. And some of the students even really benefited from graph paper. And I think I used 1 centimeter graph paper. But here we go. This is 350. And make sure they line it up. And this is 21. And then when you add it up, you get 371. And I was just so surprised at how few mistakes they made with this method. Whereas with the standard algorithm, I find that students make mistakes all the time. Where do they put the number that they rename? Straight up diagonal. My students always seem to struggle with that. But with this method, they didn't. They loved it. And I found them getting so excited about it, they were coming to the carpet for the lesson as if we were doing read aloud or something special like that. They were at my feet with their whiteboards, just loving this. Let's do another one. Let's do another one. So we did this for several days. I wanted them to be really comfortable with it, especially with lining up the numbers to add. I'm going to do one more with you, 14 times 9. I would have never thought to teach my students how to do this any other way. Here we go. 10 times 4, 14 is 10 plus 4 times 9. So we're going to go 10 times 9, and then 4 times 9, which is 90, which is 36, and when we add that up, we get 126. But this is what another thing I would have never thought to do. There are going to be some students who might think of a whole other way, a whole other strategy to do this kind of a problem. And I think it behooves us to teach our students, to show them this. This is so close to 10, right? 14 times 10. We can do that mentally, which is 140, and then you just want to take 14 away. How are we going to take 14 away? Well, you can do the standard algorithm right here where we would subtract, but I bet a lot of our students, and a lot of mine could, do this mentally. take 14 apart, which is, remember, 10 plus 4. And then take the 10 away, which is 130. And then take the 4 away, which is 126. The better we are at teaching our students to take apart numbers and look at them in different ways, it will transfer, it will serve them all their life, especially in the higher areas of mathematics when they get to high school and college. So we were just having so much fun with this. And one day, little Amelia Kay came to me, and she said, so Mrs. Matsuda, if we can use this strategy for a 2-digit times a 1-digit number, can you see where she's going? Can we use it for a 2-digit by 2-digit number? And, I tried so hard not to crack up. I just looked at her and I said, Amelia, why don't we try? I don't know. Why don't we just figure it out? See, let's work with it. Let's spend some time working with this and see if it will work. So I sent her away to her desk, and I went to my desk, and we each were independently working on this. Maybe we should have done it together, but I kind of wanted to see what she could come up with on her own. And sure enough, she figured it out. And so I presented it to the class the next day that, this was Amelia's question. Amelia has led us to the next level of multiplication. And they were so excited. And again, I find that they make fewer mistakes with this method than the standard algorithm. So let's do 63 times 27. So we're going to have to break apart both of these numbers now. This is really 60 plus 3, and this is 20 plus 7. And now we're just going to multiply everything times everything. We're going to say this is 60 times 20. Then we're going to do 60 times 7. Then we're going to go 3 times 20, and then 3 times 7. And then they're going to have to do the multiplication and add this all up. I don't want to put the addition over here. And again, lining up is essential, and graph paper can really be a blessing to do this task. All right, this would be 1200. This will be 420. This will be 60, and some of them might want to just combine these on there. They might see that that's 81 right off the bat, and they can go ahead and do that. 3 times 20 is 60, and then 21. And then we add it all up. Oh, I already had drawn a line there. We add that all up. They love it. They absolutely love this method. Some of them might not, your more fluent students, may not need this. They might go straight to here. And I did have several students who did that. 60 times 20 is 1200. 60 times 7 is 420. 3 times 20 is 60. Oops, I have to light it up. And 3 times 7 is 21. They may not need to see all of the multiplication written out. They might be able to just do it like this. And you'll be amazed to see that even some of your less fluent students are comfortable to do this. And so it did not take us long to master this method, 2 by 2 digit multiplication. I can tell you 2 areas that they'll mess up on, but it's not too often. Lining up, that's the one, I've already mentioned that. And right here, where they do like 60 times 7, some of them would just write a 42, forgetting that it's 420. So you'll want to be aware, looking for that little area. We love multiplication, 2 by 2 digit multiplication. We love it all. If you teach the standard algorithm, which Why do we teach that? I don't even know. Do you know why we put a 0 as a marker here? You know, I never knew why. Do most Americans know why? Maybe it's just me. Maybe I'm the only one who doesn't know. This is 21. That is, let's see, 42, 44. You can see where this 44 would have shown up in our other problem. Then we put a 0 here. I never knew why we put a 0 there. I just knew we did. It's right here because this isn't 2 times 3, right? This is 20 times 3. Wonderful, Stanley said, you don't need to tell your viewer friends about that. They don't need to know. And I said, well, no, I guess not, but I always wondered, and maybe you wondered too. The more proficient we can be and help our students to be with taking numbers apart, the stronger mathematicians they will be. And that's what we want. We want to send them out of our door knowing that they are math people, that we are math people, and that they are confident in taking the skills that they have learned and transferring them to other areas of mathematics. So I hope that you have found this multiplication review. Maybe for some of you it's a review, like, you know, Deneen, I've been doing this for 10 years, I already know it. But if that's the case, I hope it affirms you that you're doing well, and I hope that you maybe have gleaned something that you can use in your classroom this week. And I look forward to seeing you very soon next week.